We're going to be talking about titration math. Titration math is stoichiometry because we're going to be given one value of one substance and we need to find a different value of a different substance. Be careful that you make the chemical equation. It will be a double replacement, which will always work because one of the products is going to be water, and as a liquid, the reaction will actually happen. And please, for the love of all that is holy, do not use M1V1 equals M2V2. That is just something that we use for dilutions. This is not a dilution. Let's not use that. So we are then going to look at this. This is our first example, and notice it is a journal. We are going to calculate the grams of lead-3 hydroxide that are needed to neutralize 545 milliliters of a 3.20 molar acetic acid solution. There's a lot we have to work with here, but again, we are going from one substance to another, so we have to make the equation. I have made the equation there. You can see that it is a double replacement reaction, and one of the products is water, so this definitely works. Now, we then need to look at the things that we've been given. One of the things that we have been given is we've been given a molarity. And if we've been given a molarity, you can see that that's right here, this 2.30 molar. We have got a conversion that is in the question because that is the number one use of molarity. I'm going to be using A for my acids and B for my bases. Acetic acid is my acid, and that's going to be equal to 1 liter. Okay, so we're going to need that. Now that means we do not start with that value. Instead, we're going to start with a different value. We're going to start with the other one that's up there, that 545 milliliters. So I'm going to start with that, 545 milliliters, and we want to know the grams of the base. So this milliliters is going to be of our acid, which I'm going to mark with an A. The first thing I need to do is I need to do a metric step. I need to get this to liters. So I'm going to bring the milliliters down, change that to liters. There is 1,000 milliliters per liter. Now that it is in liters, I can go to the molarity step to change it to moles, because remember, we need to get to moles whenever we are going to be using stoichiometry. So I have got my liters of acid to moles of acid. According to my molarity, there is 2.3 moles of acid per liter in this question. After we do that, we are then at our stoich step, where we are going to go from our moles of acid to our moles of the base, in which case the base is lead-3 hydroxide. If we look here at the equality, there is 1 mole of base for 3 moles of acid. So 1 mole of base for 3 moles of acid. And then what I'm going to do now is I'm going to change this into grams. I'm going, because that's what it wants grams. So I'm going to bring my moles of base down, and I'm going to change that to my grams of base. Now there's 1 mole of base, 258.23, so 258.23. This here is going to then give us our answer. Okay, we've got our milliliters cancel, become liters, cancel, become moles of what we want, become grams. And when we do all of that, we get this. Again, we have our molarity, our stoich, our mole conversion, and we get 108 grams of lead-3 hydroxide. So again, we started with milliliters of acid, we went to grams of lead-3 hydroxide. Let's now take a look at a different version of the same sort of question. Now we want to calculate the milliliters of a 1.50 molar lead-3 hydroxide solution needed to neutralize the same stuff we had before. The same equation that we are going to use, and here we've got 2 different molarities. Now one of those molarities, actually both of them, are going to be equalities. So remember, anytime we have a molarity, it's pretty much going to be an equality. So this here is 2.3 moles of acid is equal to 1 liter of acid. Their molarity equality, and we'll do that one in a slightly different color. We have over here, that's going to be 1.5 moles of base is equal to 1 liter of base. Okay, so there's our two equalities that we have there. We are going to start, like we did last time, with the thing that is not an equality, our 545 milliliters of acid. And like before, I'm going to use metric to change that from milliliters, which is not as useful, to liters, which is more useful in this question, so that we can use our molarities. 1,000 milliliters per liter. We're then going to convert using our first molarity, in this case, the molarity of the acid, so a liter of acid to moles of acid. As we see here, there is 2.3 moles of acid per liter. We are then going to change that using stoichiometry, going from the moles of the acid to moles of the base. Again, there is 1 mole of base to 3 moles of acid, which is given by our chemical formula. Now we need to find the milliliters of this. So we have moles. What we're going to want to do is we're going to use the other molarity that we have, the molarity of the base, to get this into liters. So for every 1 liter of the base, there's 1.5 moles. That again comes from our molarity up top. We are then going to use metric because this wants it in milliliters. So we're going to times line. We're going to bring liters down, milliliters up top. There is 1,000 milliliters per liter. And there we go. Milliliters of acid to liters of acid to moles of base to liters of base to milliliters of base, which is what we want. And that gives us our answer here of 279 milliliters of the acid, of the base that we had from the 545 milliliters of the acid. Then we have a harder version of this problem where we're trying to find the molarity. Now remember, molarity is a derived unit, so we have to do one of those one string, two string stuff, except in this case we need to do some stoich as well, because we are given the milliliters of our molarity and we want to find the molarity of the other thing. So we still need a chemical equation, a balanced chemical equation to do this. And just like before, we do have a conversion factor to pull out. Our molarity here of this lead is going to be 1.5 moles of our base is equal to 1 liter of our base. So we don't need to worry about that. Now, what we need to worry about now is we need to find molarity of the acid. So we need to pull aside something. And that first thing we need to pull aside is this 454 that we've been dealing with. This 454 is actually going to be one of the starts of our problem. We are trying to find molarity when this is all said and done. So this is one of the pieces that we are going to use. We are going to have our 545 milliliters. And all we're going to do with that is we're going to change that over to liters. I'm just going to do a quick little metric conversion. Milliliters down, liters on top. There is 1,000 milliliters per liter. And this is going to give me my first number. So what I've got here is I've got 0.545 liters of our acid. All right, so I've got that. I'm going to hold that aside. Now I'm going to work with the other start that I've got here. I've got this 279 milliliters of our base. So I'm going to start with that next. I've got 279 mLs of base. I am again going to convert that with metric because I want to change that to liters. So I'm going to take my milliliters down, liters up top. There's 1,000 milliliters per liter. After that, I've got my molarity, just like I've been doing before, my liters of base to my moles of base. In this case, for every 1 liter of base, I have 1.5 moles because that is what the problem tells me. I'm then going to go to stoich because I'm changing from one thing to another. I'm going from moles of base to moles of acid. Again, there's 1 mole of base for every 3 moles of acid. This here will give me another number that I need. This will give me the moles of acid, which is part of what I need to take care of this. So 279 divided by 1,000 times 1.5 times 3 equals. So I have here 1.2555 moles of acid. Now, I want to set it up just like I have it there because what we want is we want molarity. And if we want molarity, then we need moles divided by liters. So again, this is my one string. This is my first part of the two string, my second part of the two string. So divide these, equal them together, and I will get an answer. And that will give me my 2.30 that I use in other problems. Again, as you can see here, the top part of that, the moles, came from a bit of stoich. The bottom part came from the problem itself, and together we get the molarity. So there you go. That is titration. Good luck.